Welcome to the DIY Honda Garage channel. DTC P0339 is related to an intermittent interruption in the crankshaft position (CKP) sensor circuit of the Honda Civic models from 2016 to 2021. This error can lead to potential engine starting issues, misfires, or unexpected stalling. The CKP sensor is crucial for monitoring the position and rotational speed of the crankshaft, which is vital for engine timing and performance. It is typically located near the engine block and interacts directly with the powertrain control module, PCM, to relay pertinent operational data. Understanding this DTC involves not only diagnosing the sensor itself, but also inspecting associated wiring and connectors that may contribute to this intermittent issue. Common driving symptoms can include malfunctioning engine operations leading to reduced performance, which can be frustrating for drivers. The troubleshooting process must begin with verifying the condition of the CKP sensor circuit to ensure proper engine function. CKP sensor plays a vital role by monitoring the position and rotational speed of the crankshaft to aid the engine's management system. Located near the engine block, this sensor is instrumental in providing the PCM with real-time data necessary for fuel injection and ignition timing. If the CKP sensor fails or has poor connections, it can cause a drop in engine performance or even stalling. Understanding the role of this sensor is crucial, as it influences numerous other vehicle systems, including the automatic transmission in cases where DTCs are logged simultaneously. The intermittent nature of the circuit failure can often make diagnosis tricky, emphasizing the need for careful verification and testing. When troubleshooting, one must keep in mind that if automatic transmission system DTCs are present alongside P0339, those must be prioritized to ensure a thorough resolution. The potential causes for DTC P0339 primarily revolve around electrical connectivity and sensor functionality. Poor connections at terminals can lead to unreliable signals being sent to the PCM, thus creating an intermittent error. It's crucial to inspect these connections meticulously, as any loose or corroded terminals can result in this DTC. Additionally, the CKP sensor itself may be faulty, failing to accurately read the crankshaft's position due to internal electronic issues. The CKP pulse plate, which is part of the sensor assembly, can also become damaged or poorly fixed, resulting in similar symptoms. Understanding these causes is vital for an effective troubleshooting strategy, making it necessary to rule out each possibility systematically. Each potential failure point must be evaluated to ensure the vehicle operates optimally. Symptoms related to DTC P0339 often manifest as engine stalling or misfires, particularly during idle or low-speed conditions. Since the CKP sensor is responsible for real-time feedback on the crankshaft's position, any interruption in its circuit can lead to a loss of engine power. Drivers may also notice an unexpected drop in performance, making it challenging to accelerate or maintain speed. This can lead to frustration and safety concerns, as the vehicle may behave unpredictably during crucial driving situations. Recognizing these symptoms early enables swift diagnostic action, allowing the necessary repairs to be focused on potential CKP sensor issues or related wiring problems. Ignoring these symptoms can lead to more severe vehicle performance issues, ultimately requiring extensive repairs. The initial troubleshooting step involves activating the vehicle's electrical systems by turning it to the on mode without starting the engine. Subsequently, the diagnostic scan tool known as HDS, Honda Diagnostic System, should be used to clear the DTC from the vehicle's diagnostic memory. After clearing the code, start the engine and let it idle for about 10 seconds. It's crucial during this time to monitor the OBD, onboard diagnostics, status for DTC P0339 in the DTCs menu on the HDS. If the HDS indicates failed, it's essential to proceed to the next step, as this confirms there are ongoing issues with the CKP sensor circuit. If the HDS shows passed, no further action may be necessary at this time, but the process should not be considered complete until all possibilities have been examined thoroughly. The second step focuses on real-world testing by taking the vehicle for a test drive. This driving period should last a few minutes, allowing the vehicle to operate under various conditions while monitoring onboard snapshot parameters, particularly engine and vehicle speed. Utilizing the HDS again during this driving session is crucial to capture the OBD status for DTC P0339. If the system indicates failed, you've confirmed an ongoing problem and may need to revisit the earlier steps for additional troubleshooting. If the HDS indicates passed but notes the failure as intermittent, the system may be functioning correctly at this time. However, it would be wise to inspect for any poor connections or loose terminals that could contribute to the intermittent issue. If the HDS reflects not completed, further idling until a result is shown is necessary, proving the importance of continued monitoring during this testing phase. In this step, a detailed inspection of circuit connectors and terminals is essential to identify any poor connections or loose terminals at the CKP sensor, PCM, and grounding locations. The CKP sensor connects to the vehicle's powertrain control module, PCM, which translates the sensor's data into actionable engine management instructions. The engine ground and body ground connections must also be checked, as inconsistent grounding can lead to circuit interruptions. Proper sequence and clarity in components play an important role in diagnosing DTC P0339. Should any issues be discovered during this inspection, repairing these connections or terminals will be necessary. If all connections and terminals are confirmed to be in good working condition, your troubleshooting can proceed to the next step, which involves visual inspection of the CKP pulse plate. The final troubleshooting step involves a hands-on examination of the CKP pulse plate. After removing the CKP sensor, it is critical to inspect the pulse plate for any signs of damage or wear, as this can be a common cause of the intermittent error. If the pulse plate is found to be damaged or loose, it should be replaced immediately to restore proper sensor function. Conversely, if the pulse plate appears intact, the CKP sensor itself will need to be replaced, as it may be malfunctioning despite appearing undamaged externally. This nuanced approach in understanding the CKP sensor assembly emphasizes the importance of both components for overall engine performance. Insufficient attention during this step could lead to missed opportunities for resolving the error, making it essential for comprehensive verification. After completing all necessary repairs related to DTC P0339, it's imperative to recheck the OBD status using the HDS. This will help confirm that the DTC has been successfully cleared and ensure that no new DTCs have appeared since undertaking the repairs. Following this diagnostic check, a test drive is crucial to validate engine performance and assess if the identified issues have been fully resolved. The significance of this testing phase cannot be overstated, as even minor underlying issues can affect vehicle drivability. If any new DTCs appear, further investigation will be warranted based on those codes. This meticulous approach ensures that the entire diagnostics and repair process has been effective. reaffirming the integrity of the vehicle's operations. Preventive maintenance is vital to avoid the recurrence of issues related to DTC P0339. Periodically inspecting the CKP sensor and associated connections can identify potential problems before they lead to failures. Ensuring that electrical connections are clean, tight, and free of corrosion will hugely impact the reliability of the CKP sensor's operation. Additionally, performing routine engine checks, including monitoring engine performance and diagnostic checks with the HDS, can assist in early detection of potential issues. Regular maintenance schedules are essential, giving vehicle owners clarity regarding necessary actions needed for long-term reliability. This approach not only enhances the longevity of the CKP sensor, but also improves overall engine performance, directly benefiting the vehicle's operational efficiency. In conclusion, DTC P0339 relates to issues with the CKP sensor circuit, potentially impacting engine performance and reliability. The troubleshooting process is critical, emphasizing careful verification and systematic inspection of electrical connections, sensors, and components to effectively diagnose the problem. By following the outlined steps and understanding potential causes and symptoms, one can efficiently resolve this DTC. Notably, the importance of preventive maintenance strengthens vehicle longevity and minimizes the risk of future issues. Ensuring the CKP sensor and its accompanying circuitry are regularly monitored can lead to a smoother driving experience. Overall, a proactive stance in vehicle maintenance not only aids in immediate repairs, but enhances long-term operational success. Please like and subscribe to the channel. See you next time!